In today's lesson, we are going to be looking at graphing inequalities. So this is going to be a new concept, but it's still going to borrow or use some of the concepts from the previous linear relations unit that we've looked at. Because if we're graphing anything, chances are it's going to be a linear relationship, which is what we're going to be doing today. Slightly different. So as a bit of a warm-up, at IKEA, a hot dog costs $1 and so does a drink. Think about how many hot dogs and drinks you could buy with $1 or with $5. Right? So if each one costs $1, I could have 5 hot dogs and 0 drinks. I could have it reversed. I could have 0 hot dogs and 5 drinks. Or maybe I don't get 5, I get 4 hot dogs and 1 drink. Then I get 3 hot dogs and 2 drinks, or maybe go down to 2 hot dogs, 3 drinks, 1 hot dog, and 4 drinks, 0 hot dogs, and just 5 drinks. Right, so those are all the different situations that we could be looking at, right, with $5. Next, using that, what could be an equation that represents this scenario? Well, we have a table of values. We should know how to determine the equation of a line from a table of values. We have our b value because we can clearly see our constant. So y equals something plus 5, something x. And we can check to see what our multiplier is. We can see that as we go up, we're going down by 1, as we're going up by 1. So that means our multiplier has to be -1 over 1, or just -1. I could write it a different way based on the scenario, because I know if x represents my hot dogs and y represents my drinks, whatever the x value is, plus the y value has to equal 5. Right? I only have $5. So whatever I have, the number of hot dogs and the number of drinks has to add up to 5. So different ways we could write this. But we should be at least comfortable writing it this way because that's what we spent the whole unit doing. Now, do you think this will be linear or nonlinear? Well, it fits this format. We can see that it's increasing by a consistent amount, right, or decreasing in this case, so it should be linear. It should be a linear relationship. So let's graph it. So we're at 5, 1 and 4, 2 and 3. So this is our linear relationship. We have drinks on the side, and we have hot dogs on the bottom. So all we're doing is just graphing the points. Now, what if we had $10 to spend on drinks and hot dogs? What would our line look like now? Well, right, we could go through, create a table of values and look at all the different possibilities, or we could take the same kind of relationship that we looked at, where if I know the number of hot dogs, x, let me say hot dogs, plus number of drinks has to equal $10. So let's look at all the possibilities where the x and the y value, or the two coordinates of our points, add up to 10. So drinks, hot dogs, oops. So we could have 10 drinks, no hot dogs. We could have 9 drinks, 1 hot dog, 8 drinks, 2 hot dogs, 7 drinks, 3 hot dogs, and so on. You can probably see where we're headed. Very similar to the last one. So that is our equation, or graphically. So that's what our line would look like. Now, what if we wanted to spend less? than $10. What would that look like? Well, let's think of it, right? What would be a point where we would be spending less than $10? Well, if everything along this line is spending $10, then spending less than $10 would be like a point over here or over here, right? This would be 5 drinks and 1 hot dog. Here we would have 4 hot dogs and 3 drinks. I could have 1 of each, right? I could have 9 hot dogs and 1 drink. I could have 9 drinks and 1 hot dog, right? Any point that I put below this line would work, would satisfy spending less. So I don't need to put all those points in. What I could do actually is I could actually just highlight or shade in everything below, because everything below that line would be less than $10, every point below that. So if I wanted to represent this as well, based on the equation that we have, the number of hot dogs plus the number of drinks has to be less than $10, or less than 10. Now, what if we wanted to spend more? Well, let's think of points that would give us more than 10, right, or $10 spent, right? So it could be 1 hot dog and 10 drinks, because that would work out to $11. It could be 15 hot dogs and 15 drinks. It could be 10 hot dogs and 15 drinks, right? It could be 10 hot dogs and 10 drinks, because that would be $20. The idea is anything above this line, anything above here, anything above this blue line would be considered spending more than $10. So I can actually just highlight everything, because the only stipulation is that it's greater than 10, or it's more than $10. So if we think about what we have then, or how we can represent that as an equation, similar to the last one, because it was x plus y is less than 10, then in this case, x plus y is greater than 10. Because all these values added together will work out to greater than 10. So this idea, specifically these last two here, these two are what we call inequalities. Now, inequalities are similar to equations, except they do not use an equal sign. And the signs that may be used we see here, right? Usually we read them left to right. So this would mean that the left value, so the value is less than the right value. Here is the left value is less than or equal to the right value. This means that the left value is greater than. And the last one is greater than or equal to. So these symbols are what we're going to be using in our equations now, or equations of a line, to represent inequalities. Right? If we want to remember what those symbols are, again, there's different ways to think about it. Right, less than, so value on the left is less than the value on the right because you're at the small side of the symbol. Same thing, reverse, left side is greater than the right side because the bigger side of the symbol is on the left side. If we add a line just underneath, that just means it's greater than or equal to. You could think of it as like a mouth, right? And the symbol wants to eat the larger one. Right? We still read it left to right, so we wouldn't say the right is greater than the left, which it is, but we usually read left to right, so we'd say this value, this cupcake is less than this one. Or we might say this pizza is greater than this pizza. So again, just different ways to think about it. You've probably seen some of these before. Right. Next, let's go through and we're going to graph the inequality. So we want to graph the inequality. So y is greater than or equal to 4x plus 2. Now to recall, to graph an equation of a line, we plot the y-intercept and then use the rise over run to plot other points and then draw a line through those points. So right now, this looks very identical or very similar to y equals 4x plus 2, which we should know how to graph. We've done that before in our previous unit. We've looked at that in some of the lessons in this unit as well. We want to start with our b value, which is 2. So our b value. And then we want to get our m value as well, our multiplier. In this case, it's 4. And we're going to graph it as we normally would. Right? So we start at 2. And our m, or our rise over run, or 4 over 1. So that means we go over 1, up 4. Over 1, up 4. Over 1, up 4. And I'm going to just connect those dots now. I'm going to put arrows on the end because it's signifying that this line will continue on forever. Now, the only other thing that we need to do, this would be if we graph the line, right? That would be for this only. So we've graphed this line. In order to graph the inequality, we need to recognize, what does this symbol mean? Well, this symbol means that y is greater than or equal to 4x plus 2. So if everything along here is 4x plus 2, then greater than or equal to is going to be everything above the line. So I'm just going to shade in everything above the line because it's representing every possible value that would be greater than or equal to. So I would shade everything above. So that shaded part is the inequality that we're talking about. The equal part, right? How do we represent the equal? And we'll look at this in some of the other examples. This would just be a solid line. Right? So if we're dealing with something that's equal to, we're talking about a solid line. And we'll look at an example where it's not equal to. So next one, graph the inequality. 2x plus y is less than or equal to 14. So this is in standard form. And in order to convert this or write this in, or to graph this, I want to write this in the y equals mx plus b form. So I have to work on moving things across the inequality, similar to what we would do if this was a normal equation in standard form. So I'm going to have 2x plus y is less than or equal to 14. I'm going to bring the 2x over. So I get y is less than or equal to negative 2x plus 14. I now have my m value, which is negative 2. I have my b value, which is 14. And now I can graph it. So the first thing I'm going to do is graph it as if this was just an equation of a line. So I'm at 14. That's my starting point. My multiplier or my slope tells me that I go down 2 and over 1. Drawn enough points. I've drawn at least my 3 so that I can go through now and just draw a line or connect them. Put arrows. So this line right here is just y equals negative 2x plus 14. So that's what we would be doing if we were just drawing the line. We don't want to just draw the line though, we want to include the inequality. And the inequality in this case is saying that y is less than or equal to. So less than or equal to would be below the line. So I would shade everything on my graph below the line. Again, just trying to make it nice so that I'm not going above. But as long as you get the idea that less than would be anything below the line. And because it's also equal to, it's a solid line. So that's like a solid line that we've drawn. Next one, okay, graph the inequality x plus y is greater than 8. So again, same idea. This is in standard form. I want to rewrite it in y equals mx plus b form. Granted, it's not equal, but the inequality would just replace the equal sign. I'm going to move the x over. It becomes y is greater than negative x, opposite signs, plus 8. I have my multiplier, which is -1. I have my constant, which is 8. So now I can graph this. I'm at 8. I go down, down 1 over 1, down 1 over 1, down 1 over 1, and so on. I'm just connecting. I can connect my points. I'm speeding through this part a little bit, but we have had a lesson. We have talked about how to graph equations. So if you need to go back and review that, please do so. But we've graphed our line. So now we have y equals, this is y equals negative x plus 8. Now, the inequality is saying that y is greater than. There is no second line underneath, so it's not equals to. So what we actually have to do is we have to, well, let's draw in what we mean by greater than. So greater than would be anything above the line. And I probably picked a bad grid for this because it's a lot of highlighting. Hopefully you get the idea. Greater than, so it's everything above the line. Now, because it's greater than and not greater than or equal to, we actually have to go back and do something with our line. And what we have to do is we actually have to make a dotted or a dashed line. So this line is not going to be completely solid. So if you get an inequality that says greater than or less than and there's no equal to, it's a dotted line. Because the line represents the equal to. So you can almost think, well, is there a line underneath? No. Well, then there should be no line for my dots, right? Or no solid line, right? You still need to have a dotted line to represent that dividing, but it's a dotted line, not a solid line. Next example, graph the inequality 4x minus y is greater than 3. So if I rearrange, right, I want to get this into y equals mx plus b, or very similar to. I'm going to move the 4x over, so I get negative y is greater than negative 4x plus 3. I want to get y by itself, so I have to divide by -1 on both sides. And now here's a small little complexity, I guess you could say. When multiplying or dividing by negatives, the inequality switches. So this is a complexity to working with or rearranging with inequalities, is that when you're multiplying or dividing by negative numbers, the inequality switches. So what that means is you're dividing by -1 to get rid of this negative in front of the y, so it remains y. The inequality now switches from greater than to less than. The numbers then we work through, so 4x minus 3. So by dividing by a negative value, we have to switch that inequality. So that's one kind of complexity when working or rearranging inequalities. But now that I have my values, my m, which is 4, my b, which is -3, a little bit off, but I plot so I go over 1, up 4, over 1, up 4, and I'm going to graph my line. Because it is only less or only is less than or equal to, or sorry, only less than, I'm going to do a dotted line. I'm not going to do a solid line. This is less than. And that means that I have to highlight everything below the line. So again, I picked a bad grid for this because it's a lot of highlighting. So we've looked at all the different kind of examples that we might have had when dealing with graphing inequalities. The next thing we want to do is determine an algebraic representation for the shaded portion. So now we're going to come up with an inequality for the actual graph. And this is going to be very similar to looking at or coming up with the equation of a line. Right? So we're looking for the same thing. So we have our line, we have our b value. We go down the axis, y-axis, we find our b value. So b is equal to -3. We find two nice points to find our multiplier, or rise over run. So we go over 1, 2, we go up 1, 2, 3. So my multiplier is equal to 3 over 2. Right now I have y equals 3 over 2x minus 3. The only other thing now that we have to take into consideration is the shaded portion. So the shaded portion, is it above or below? Well, because it is below, that means that it is going to be less than for our inequality. Let me use purple to represent all the inequality stuff. So it will be less than, so y is less than 3 over 2x minus 3. And also, the other thing we want to notice is that it's a solid line. So that means it's less than or equal to 3 over 2x minus 3. So we're going to determine the equation of a line similar to what we've normally done. And then when we look at the inequality portion, we look at which portion of the graph is shaded, above or below. Above is greater, below is less than. And then we look to see if it's a solid or dashed line. So let's look at the next one. Again, we're only going to worry about determining the equation of the line first. So find the b value. So b is 1. Find two nice points to find our multiplier. Rise over run, so 1, 2, 3, 4. So over 4, up 1, 2. So my multiplier is 2 over 4, or 1/2. So we have y equals, or I guess we'll leave that blank for now because we know it's not going to be equals. So y 1/2 x plus 1. And we need to look at our inequality portion. So the shaded part is below, and it is a dotted line. So that means that below is less than, so y is less than 1/2 x plus 1, and the dotted line means that it is not equal to that line. So y is less than 1/2 x plus 1. That is our equation for the inequality. And last example, Same idea, same kind of steps, just different scenarios. So go down your y-axis. We have our b value. B is equal to 5. Find two nice points. Find your multiplier, or rise over run. So over 1, down 1, 2, 3, 4. So your m value is -4 over 1, or just -4. So that means we have y -4x plus 5. And for our inequality portion, we look at the shaded region. So the shaded portion is above. So that means it would be greater. And it's a solid line, which means equal to. So the equation for this inequality would be y is greater than or equal to -4x plus 5. And that would be our algebraic representation, or our inequality for this graph. So just more of a lesson application of linear relationships to represent an entire portion of the graph, introducing different symbols, less than, or greater than, or including the equal to portion of those two scenarios. So hopefully by the end of this, you're able to determine the algebraic representation for an inequality and and graph the inequalities.